Hey everyone, we have covered the this method, and I ended off with this example of we are not able to use this method if we have this graph and we rotate it about the y-axis, right? Because there's no this to be formed with the y-axis, right? Because if you draw the line, it's actually this area here. But we're looking at the areas from, let's say x equals to 2. Let's say this is like 2 and then this is some 4. You realize that if you want to find the volume of revolution from x equals to 2 to x equals to 4, and we rotate it about the y-axis, there's no disk to be formed, right? Because we're looking at this area here. But then if we get to get the disk, right, it's these areas down here. So we cannot use a disk method. As such, what other methods are there can we use to actually find the volume of revolution? The answer is that there is something called the shell method. Alright, so the shell method, as the name suggests, we are going to consider shells instead of disk. And it's not the type of shells that we are thinking of, right? It's more like a circular ring. Alright, what do I mean? So we know that keeping with the trend of taking multiple widths, right, we're going to cut the area, or actually the volume, into small widths. What we do is when we rotate around the y-axis, we're going to get the corresponding cuts as well, right? So what happens is that instead of our volume being like disk, our volumes are now like a casing, right? So it's like a ring. So what happens is that you just imagine, right, if I were to just take like a strip, let's say this strip, and I rotate it around, let's say it corresponds to this one, and then from the front, I will get a ring, right, an open ring of of certain height and width, right, a 3D shape. So I'll get an open ring, and if I were to just flatten this ring, just let's say like unloop it, I'll get a long rectangular bar, right? So I'll get a long rectangular bar of something like this, right? So imagine that is the idea of a shell method. It's like taking a Swiss roll, but then instead of cutting it, you will like unwrap it. So it's like, baking a Swiss roll, right? So you put the sponge, you put the cream, and then you roll it around. The shell method is that you unroll it, right? That's the whole idea of a shell method. So again, how do we use integration? So we know that the widths here are delta x, right? So over here would be delta x, this horizontal width. The height here, so this height here is y. The length here is basically the circumference, right? Because you took a whole ring and then you unloop it. So we are basically taking the perimeter of the circle, right? So taking the perimeter, so it's 2 pi, so the radius, which is basically from here to here, correct? So x. All right. So we then have the formula. We have infinite numbers of these rectangular strips. So we then have 2 pi xy dx, right? Because it's delta x. So basically the shell method is 2 pi xy dx. Now, just a very quick one. If I were to rotate about the y-axis, right? So let's say, sorry, about the x-axis now. So this is about y-axis. So this is now the x-axis. If I were to rotate about the x-axis, so let's say there's the same graph here, something like this, the area where we want to find is down here, right? The volume, right, that we're rotating about is down here. But then when we rotate it about the x-axis, it will be down here. So using the same idea, we now have a horizontal strip, right? So something like this. I'm trying my best here. I'm not really good at art. Okay, I tried my best. Okay, so again, what is the height of each? What is the width of each one? Here will be delta y, right? Delta y. The height here, so this thing here, so it basically corresponds to here, is x. The length now, basically taking the circumference of the ring, right? Which is basically from here to here, which is y. So we have 2 pi y. Therefore, if we were to sum all the rectangular strips together, we will get 2 pi xy dy. Alright. So in a nutshell, with no pun intended, so we have the shell method. So the shell method basically, about the x-axis, it would be 2 pi xy dy. About the y-axis, it would be 2 pi xy as well dx. So what's the difference between the shell method and this method in terms of memorizing the formula? In this method, whatever axis you are rotating the figure about will also be the variable they are integrating with respect to. So for example, in this method, you rotate about the x-axis, it will be dx. About the y-axis, it will be dy. In the shell method, it is the opposite. If you're rotating about the x-axis, it will be dy. About the y-axis, it will be dx. And of course, the formula inside will be different. It will be xy for both the shell method. It's actually the same. It's just that in the shell method, the only thing that's different between about the x-axis and the y-axis is the variable they are integrating with respect to. Again, when do you decide to use a shell method? To put it simply, look at the area or the volume that you want to find. This is the area and the volume, right? Take a line and you draw towards the nearest axis that also encompasses the area. So this is the area. You take this from the curve to the axis. So the nearest axis is the x-axis, right? Obviously, you can't draw the y-axis, right? Because that wouldn't encompass the area. If you notice that it is different from the axis that you are rotating about, right? So let's say you're rotating about the y-axis, but you can only draw to the x-axis, it will be the shell method. So simply put, if the lines that you draw are parallel to the axis that you're rotating about, it will be the shell method. If it's perpendicular, so let's say you want to find this volume, the red volume here, you notice that if you rotate it about the y-axis, the lines are perpendicular, right? And the lines also touch the y-axis, it will be this method. So here it will be shell. So let's say this is rotate about y. Then the red one would be the disk method. Don't worry, more of it will be covered in the comparison video. Alright, so there we have it, the shell method of calculating the volume of a revolution. And I'd like to say that this method is only found in the H2 further math syllabus. You can use it for H2 math syllabus, although you run a risk of being penalized if you get it wrong.